Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera to Dr. Shamsatun. Our group member consists of me. My name is Rafeesya Binti Ridzuan.
My name is Solehah.
My name is Farah, Nabila, Binti Rahim.
And my name is Irdina, Syakirah.
And today we will present about application of differentiation. My name is Rafeesya Binti Ridzuan and I will start this presentation. So first of all, related rates. Related rate is the rate of change of one quantity in terms of the rate of change of another quantity whose rate of change is known. There will be an equation that relates the two quantities, and then we can use chain rule or implicit differentiation method to solve the problem. The rate that have been identified could be increasing or decreasing, which will determine the value should be in positive or in negative.
I will continue the presentation. My name is Farah Nabila binti Rahim. Analysis function 1. In analysis function 1, there are increase, decrease and concavity. These are used to describe the behavior of the function over an interval point as we travel from left to right along a graph. Concavity is the shape of the curve, which is like this and like this. Next, increase in interval and decrease in the interval. The interval is increased if fx1 is smaller than fx2, and then vice versa to that, decrease in the interval happen if fx1 is bigger than fx2. Okay. Then we're gonna go through the concavity. Concavity linked to the second derivative of fx. If the second derivative is positive, and then it's gonna concave up, and if the second derivative is negative, and then it's gonna concave down.
So for next slide is back to me, Rafeesya. We will talk about analysis function 2. There will be two derivative tests, which is first derivative test and second derivative test. For first derivative test, it will help us to determine the value of relative maximum or relative minimum based on the graph extending left or extending right. If f inverse x more than 0 extending left and f inverse x less than 0 extending right, you will get the value of relative maximum. While f inverse x less than 0 extending left and f inverse x more than 0 extending right, you will get the value of relative minimum. For second derivative test, if f inverse more than 0, you will get relative minimum, while f inverse less than 0, you will get relative maximum. Next, after solving the problem, you have to sketch the graph of analysis of function 2. There will be two different functions, which is polynomial function and rational function. For polynomial function, the graph should consist of x and y intercepts, critical points, relative extrema, interval points, concavity, and inflection points. For rational function is an algebraic fraction that both numerator and denominator are polynomials. We can find this function by using the formula fx equals to numerator px divided by denominator qx. The value of denominator could not be 0. If so, the function is invalid.
Now I will continue with the presentation. My name is Solehah. I will be explaining on how to find asymptote for rational function. In order to find vertical asymptote, you have to locate where the function is undefined and where the simplified equation denominator is equal to 0. As for the horizontal asymptote, for the first case, where the degree of numerator is less than degree of denominator, therefore asymptote y equal to 0. For the second case, the degree of numerator is equal to the degree of denominator, therefore the y asymptote is equal to term numerator divided by term denominator.
Name is Irdina, Syakirah, and I will continue to present about maximum and minimum values. Firstly, if fx is continuous on AB, then there will be exist numbers of c and d in AB. So fc will be the minimum value of fx and fd will be the maximum value of fx. Then each value of c and d will either be critical points of fx and one of the endpoints of a and b. Next, I will continue about absolute maxima and minima. So firstly, we will let I to be an interval in the domain of function f. So the condition is that if f has an absolute maximum at point c on interval I, then fc will be the largest value of f. Otherwise, if f has an absolute minimum at c, then fc is the smallest value of f on I. So both maximum and minimum value of f will be called actual values. So in general, there will be no guarantee that a function will actually have an absolute maximum or minimum on a given interval. So next one is to define local maximum and local minimum. So to define is that firstly, if fc is larger than fx when the x is near c, the fc will be the local maximum of f. Otherwise, if the value of fc is smaller than fx when the x is near c, fc will be the local minimum of f.
Next, we're going to continue with applied maximum and minimum problem. Firstly, my name is Farah Nabila Binti Rahim, and in this part, we're going to learn about applying of the previous subtopic maximum and minimum values in problem solving. The question could ask for values, or the question could come in various shapes. As for example, in this one, they ask for the values of x that will give the highest value or the maximum values of a, which is area.
Topic I, Nawi Solehah, will be presenting about Rolle's theorem and mean value theorem. For Rolle's theorem is when we let f be a function that satisfies these following three hypotheses. Firstly is when f is continuous on the closed interval ab. Second is when f is differentiable on the open interval ab. Thirdly is when fa equals to fb. Only then will there will be a number c in fb such that f inverse c is equal to 0. Lastly is mean value theorem. Mean value theorem is when we let f be a function that satisfies the following hypotheses. Firstly is when f is continuous on the closed interval ab, and lastly is when f is differentiable on the open interval. Only then where there will be a number c in ab such that or equivalently as the formula shown below.
Given function fx, the question asks for x-intercept and y-intercept. So first we need to simplify the fx given, and then to find for the x-intercept y equal to 0. And then we substitute the y equal to 0 into the function, and then we get x equal to 0 and 6. And then in order to find the y-intercept, we need to substitute the value of x, which is 0, into the equation, and then we're going to get y equal to 0. So in conclusion, x-intercept is 6, 0 and y-intercept is 0, 0.
So next, we have to find the critical points of f. To find this critical point, we have to find the value of x first. And to find the value of x, we have to differentiate this function and we will get this. After getting this function, we have to factorize and we get x equals to 0 and 4. Next, we have to substitute this value, 0 and 4, into the first fx function. So we will get 0 and negative 32 over 3. Then we substitute this 0 and negative 32 over 3 again into the function to get the value of y. So therefore, the first critical points is 0, 0 and 4, negative 32 over 3.
Next, we will find the intervals where f is increasing or decreasing. For this, we will be using the value of x, 0 and 4, and to choose any number from the range to test it out on the first derivative of function. And if the answer we get is in positive form, it means it is increasing, while negative means it is decreasing. From this, we can see that f is increasing on negative infinity 0 and 4 infinity, while decreasing on 0, 4. Next, we will find the relative maximum point and relative minimum point. We will once again use the value x, 0, 4 and use it in the function to find point y for both the relative maximum point and minimum point. And the answer we will get is 0, 0 for the maximum point and 4, negative 32 over 3 for the relative minimum point.
Next, we have to determine the interval whether it's concave up or concave down by using second derivative. So the answer of second derivative will be x equals to 2. Then we have to test the value. If the answer is negative, then it's concave down, while if the answer is positive, then it's concave up. Then we have to substitute the value of x into the function of f to get the inflection point of f. So the answer will be 2 and negative 16 over 3.
Next, we have to sketch the graph using the information we have found. So first is x and y intercept. Our x and y intercept is 6, 0 and 0, 0. Our critical point is 4, negative 32 over 3 and 0, 0. Our relative minimum and relative maximum. This one is minimum and this one is maximum. Our increasing and decreasing is, this is increasing, this shows increasing, this shows decreasing, and this one shows increasing. Next is concavity. This one shows concave down and this one shows concave up. And the inflection point is middle here. The behavior of the graph at negative or positive infinity is straight to top and straight to bottom.
Let us
was all from us. Thank you so much.